This is for sheet number 3. This is for written equations. Now you can see these written equations look a little bit different than the other example problems that I have from previous notes or previous screencasts. So let's take a look. First of all, before we get started, let's take a look at our 3 steps. Our 3 steps look like this. You should have seen them in the notes in the assignment. The description of the assignment has the 3 steps for what we call word equations. And the 3 steps are this. Step number 1, symbols and charges, if it's an ionic compound. Prefixes, if it's a covalent compound. And Brinkelhoff, if it's a single element and it happens to be bromine, iodine, nitrogen, chlorine, hydrogen, oxygen, fluorine. Each one of these needs a 2 after it because when they combine, when you have bromine as an element, it combines with another bromine to always give us Br2. Now we're really actually, we're already aware of this because every time that you see oxygen, you see it as O2. So we're already used to seeing oxygen like this. There just happens to be 6 other elements that do exactly the same thing. You probably have seen hydrogen like this, and you probably have seen nitrogen like this. So we just have to include chlorine, iodine, and what's the last one? Fluorine, it looks like. Okay, so all of these elements then, and we can remember them easily by saying Brinkelhoff. And if you can spell Brinkelhoff, then you know the 7 diatomic elements. Okay, so that's step 1. So let's take a look at step 1 for number 1. So magnesium bromide, magnesium is Mg with a +2. Bromide is Br, and that has a -1 because of where it is, plus, and then chlorine. Now this is Brinkelhoff. It's not just Cl, it has to be Cl too. It has to be, okay? And you've got to remember Brinkelhoff. And then on the other side you see magnesium with a +2 and chloride, which is Cl with a -1, and then plus bromine, but because bromine is part of Brinkelhoff, I have to put a 2 there, like that. Now, what's my second step? My second step is crisscross. So for all of those things that's not prefix or Brinkelhoff, now I have to go back through and crisscross. So let's crisscross here. I got a +2 and a -1, which means once I get rid of these charges that I get a 1 and a 2. So my 2 comes down to give me MgBr2. You should have seen this before. This should not be a surprise. Just a review. So I got a 2 and a -1, which means MgCl2, like that. And then my last step for word equations is balancing the equation. Okay, so when I go forward here, I got 1 Mg. Some people like to write it out like this. I got 1 Mg on this side and 1 Mg on this side. I have 2 Brs on this side. I have 2 Brs on this side, and I have 2 Cls on this side and 2 Cls. So actually this is all balanced. Some people like to put a 1 in front. You won't after a little bit, but you can show that it's all balanced with a 1, 1, 1 like that. And that means the numbers in front of each of the parts of the equation. Okay, so we're all finished with that. So that's number 1 finished. 3 steps. When you get good at this, you don't have to go through all 3 steps as long and drawn out as I did. So let's go through the 3 steps again for number 2. So I write down sodium. So I'm writing down symbols and charges, prefixes, and Brinkelhoff, but sodium is not part of Brinkelhoff, so it does not get a 2. So it's just sodium. I write the symbol down, and because there's a plus here, that means it's not part of any other compound. So it's just Na. And then water is a common name for a formula of which we know, H2O, so I can write that one out just like it's a prefix or something. And then I write down sodium with a +1, and hydroxide is a -1. I write down the symbols and charges to do the prefix, to do the crisscross later on. Hydrogen is Brinkelhoff, so that needs a 2. Okay, sometimes it helps if you write Brinkelhoff at the top of the paper so you can keep checking to make sure that you have Brinkelhoff. Remember, it's only Brinkelhoff when hydrogen is by itself, just like sodium over here is by itself, but sodium's not one of the 7 that gets a 2. Okay, so if you see hydrogen or oxygen like this in a compound, there is no Brinkelhoff. The element has to be by itself, not in a compound. That's very important. Okay, so let's keep going here. So I have Na with a +1 and OH with a -1, so it's just NaOH. I'm going to erase this and just write out the thing. So it's NaOH, just like that. Now let's go through and do our, that was the crisscross right there. So that was step number 2 because we didn't have to crisscross anything because it was a +1 and -1. Now let's go to balancing. So the balancing looks like this. I have 1 Na here, right? I have 2 hydrogens here, and I have 1 oxygen here. Okay, so when I go to the other side, I have 1 Na, I have 1 oxygen, and here I have a hydrogen, but then with these 2 here, I actually have 3 hydrogens total. Okay, now here is a trick. I know that I can balance the hydrogens if I double this, because this hydrogen only has a 1 here, which means I can double that one, and that will give me a total of 4 hydrogens. Now, since I've doubled that, that's going to also mean I need to double this to get a number of 2 sodiums. So now I have 2 sodiums, I have 2 oxygens, and I have 4 hydrogens total. So over here I have 2 sodiums, because I put the 2 in front of the Na, and if I put a 2 in front of here, I now have 4 hydrogens, and 2 times 1 is 2 oxygens. So now I've just balanced the equation with a 2, a 2, a 2, and this one stays a 1. So that looks like this. So here's what I typically do. Notice that you have a 2 on this side, and you have a 1 on this side before we get started with the balancing. So basically, I double the one that's a 1, so that now I have an even number of hydrogens on both sides. And then I can go back and balance the hydrogen pretty easily. Okay, let's take a look at number 3. Number 3, the only reason why I'm doing number 3 is so that you can see that for number 3 it says plus heat. So let's go through, let me do my step 1. My step 1 is in red, and my step 1 is in green, and it is symbols and charges. So potassium is a +1, nitrate we know is a polyatomic ion with a -1, like that. And then this says plus heat. I'm not going to show the plus heat. If you want to, you can show the plus heat with a triangle on top. But if that triangle's not there, that's not that big a deal. So plus heat means K with a +1, NO3 with a -1. Here I have K again, and it's still in a compound, so that means symbols and charges. This time nitrite is a -1, that's NO2 instead of NO3, and then plus oxygen. Okay, so remember for step 1, we do symbols and charges, prefixes, which I haven't seen a prefix yet, and Brinkelhoff. Do you spot a mistake anywhere on here? Did I do something wrong for step 1? Well, if you're paying attention, step 1 includes Brinkelhoff, and I have to make sure I have my subscript 2 for oxygen. Now let's go through and crisscross. Crisscross looks like this. I get rid of my +1 and my -1. So now I just have KNO3, and over here I do the same thing. KNO2. That's a 2. That was not me, that was the computer. That's still not a 2. Are you kidding me? This is killing me. There. Okay, So KNO3 yields KNO2 plus O2. So that's where we are for step number 2 after we've done the crisscross. Now let's do step number 3. Notice I have 1K here and 1N and 3 oxygen. And over here I have 1K, 1N, and here is 2 oxygen, oops, 2 oxygen, but over here are 2 more oxygen. We always do oxygen last. Everything's balanced except for oxygen, so now we have to do oxygen. So if I have 2 oxygen here and 2 here, I have an even number. So how do I get an even number on the left-hand side when I have 3 oxygens here? That's easy. I do what I always do in a situation like this, which is double the number of odd oxygens I have. If I put a 2 in front of the whole compound, that means I have 2 Ks, 2 Ns, and 6 oxygens. Now let's see what happens over here. That means I need a 2 in front of here to get 2 Ks, 2 Ns, and then this will give me 4 oxygens. So now I have 4 oxygens here where the 2 is. 2 times 2 is 4, and then I'm going to add that to the other 2 oxygens I have here to get a total of 6 oxygens. Okay, that's not 6-0, that's 6 oxygen atoms. Okay? So my O's and my zeros don't look the same. That's I put the X after it just so you can see it's oxygen. Okay, so now I have 6 oxygens on both sides. I have 2 potassiums on both sides. I have 2 nitrogens on both sides. Notice I can't keep, I've often talked about polyatomic ions being like you keep them from one side to the other, but there is no NO3 on the other side, so you can't do that here. You have to break it up into the number of N's and the number of oxygens, like I did on both sides. Okay, excellent. Please let me know if you have questions. I'll talk to you later.